Alright, so let's talk about the spatial position in a binary matrix. So given the n by n matrix, so a spatial position in matrix is going to be represent you are the only one in a column and in a row. So this is how spatial you are. So all of the element in the row I remain 0. All of the element in the column remain 0. So I'm going to talk about two solutions. The first solution is going to be, the brute force at traversing every single cell. If the current value is equal to 1, I check my what? I check my vertical, horizontal. Alright, so, and then if they are passing, increment. Alright, so this is straightforward. So let's, just start coding. So for in I equal to 0, I less than mat, dot length, I plus plus. For in j equal to 0, j equal to 0, j less than mat, dot 0, dot length, j plus plus. If mat ai j equal to 1, right? And then we want to say if verify mat ij plus verify 0. So what does verify 0 represent? It takes mat, it takes what? X in y. So I want to condition check. Check vertical and horizontal are all 0. So I'm going to traverse in I equal to 0, I less than. So vertical goes first, right? Doesn't matter. Alright, so if I want to check vertical, right? If I want to check vertical, my y is not changing. My y is not changing. My I is changing, right? When I is changing, I changing the row, right? So this is why I using the method length, not this guy. This is checking the other condition. Alright. So if this guy equal to 1, I return false. So if there's an element in this column is equal to 1, I return false. So here's a problem. What happened to this value, right? We want to what? We want to skip this value. So if I equal to y, sorry, if equal to x, sorry, continue. So you will be, you skip this condition check, but you're still going to check this guy. I mean this guy and this guy. All right. So another way of writing this is what? Okay. Here we go. So it's straightforward to if. All right. Next one is going to be similar. So it's going to be checking, you're changing a column, right? You're changing a column, but your row is not changing. So this represents x, this represents I, and you don't want to, hit your column, right? This guy is what? Y. So at the end, you want to return true. So this is pretty much the solution. Submit. Alright, let's talk about, it's passing. Let's talk about time and space. All of n, all of m. Inside here, you have all of n, all of m. So the worst case is going to be what? This guy. mm, then you want to pick your maximum. If this is longer traversal or this one. And then the space is constant. You're not allocating space. The second solution is actually pretty, unique and saving a lot of, time to traverse. So I'm gonna have what? The counter for rows and columns. I'm going to record how many how many 1 in a row. So it's gonna be rows 0, you have 1, rows 1, you have 1, rows second, you have what? 1, and then columns 0, you have 2, right? Column 1, you have 0, column 2, you have 1. So when we want to traverse, so here's a trick. We're still going to be using the 2 for loop, but we want to make sure our rows at I equal to 1 and columns at j equal to 1. Then we will increment. This is how to find the unique, the spatial number. Alright, so too much talking, let's start coding. Alright, in column, let's say rows equal to new int math.length, columns equal to new int math at 0.length, and then I will say for in I equal to 0, I less than math.length, I plus plus, for in j equal to 0, j less than math 0.length, j plus plus. And then I'm going to say if math at ij equal to 1, I add my rows at I plus plus, columns at j plus plus. So I'm still adding the I and j accordingly to their content array. And here we go. So copy paste, but in this time we want to make sure if rows at I equal to 1 and columns at j equal to 1, then we increment the result. Only if the math at I j equal to 1, right? It will be like this. So we're checking the current cell. The current cell is 1, right? Then we check am I the only one, right? Am I the only guy in the current, the current vertical or horizontal? If I'm not, then it's basically an increment. I increment if this satisfies. So submit. Alright, so time and space are a little bit different. So in this case, all of n times n, all of n times n, and the space you allocate the space, all of m, determine which one is the largest, then you will just use it. But ideally they are the same, right? It should be like a square or what, something like this. Alright, the solution is pretty straightforward, and if you still have questions, leave a comment, and I'll see you later. Bye.